I haven't seen localization, but lately, like the last week, actually the last week, up till Thursday, I explored that package. When I get a chance, load the open source over, and I actually loved it. Um, the, their their software side of the things, they're really cool. Their mechanical side of the things, the electrical side of things, this assembly for the whole rower. Actually, the design is very nice. And then everything is in Python, and then we have actually a lot to leverage from there. So
That's on the JPL rover?
yes,
Okay. Jet Propulsion Lab, Mars rover.
correct.
Probably a good place to
Beautiful
start.
design.
They may know what they're doing, huh, Walter?
Sort of a clue, maybe.
Yeah.
But do they have good safety systems?
That's
in
right.
case something runs out in front of them on Mars.
Yeah.
I'm not sure if they really care about that.
There's a lot of paperwork when you run somebody over on Mars.
We don't even know what form of life might be there.
That is very true. But I like the design of the Ackerman, and then there's some fundamentals, some concepts. Actually, it made it very clear that how you can design the Ackerman. And also, I like their absolute encoder, that how they utilize that. There are a couple of things to leverage from there if you ever wanted to actually put the encoders, and then I think they're pretty consistent. The encoders are not actually cheap, and they're reliable. So it means that we can utilize those if need be, kind of deal.
Excellent. But still an unknown.
Yeah, well, I'm just actually imagining their Python code and side by side and putting it into the ROS perspective and trying to kind of visualize that if I can see any fit, and see if we can leverage any of this code into the ROS and utilize those in what you're trying to build. And I think there are a lot of places where at least the low-level hardware side of things and electronics side of things that actually made some of the things very clear about that how you can do it and how you can leverage that and put it into the ROS. So there are sort of competing ideas into my mind, and just trying to put that, note it down, just see that if everything, kind of comes together and converge at one point. Well, we see.
Excellent. A lot of great projects and just tons of stuff to learn. It's cool to see different implementations.
Right.
Tonight we have a special presentation from Soen on his Agbot and maybe the safety system. So I'll cover both the topic and the presentation.
Hopefully, yes. Not all of it though. It's a less technical one. It's called Things We've Learned from the Agbot Challenge, and it's going to be something that we should have known, or we wished we knew before we started building stuff up. And as the thing gets more and more complete, it's more difficult to change it from a systems engineering perspective. So that's what I'll be talking about today. Me pull this up and whoops. No.
Okay, so I'll be taking notes.
Sure. This one. Right. Can you see it? Can you guys see my screen?
Yes, I can.
Yes.
Okay. Okay. So yeah, lessons learned from the AgBot challenge. Uh, that's our AgBot. I'm just going to go through different systems. I won't be talking about the spray system because that is that is another topic, and most of us aren't concerned with how we spray. Navigation is the big problem that we're all trying to solve here. So I will keep it more relevant to the group that we have here, and we'll just talk about uh, navigation. Oops. No. Okay. So for steering, we use ROS serial, Arduino, H-bridge, the stock EPS system, and the rotary encoder for feedback. Now that's the rotary encoder. That's how, and that's the EPS system. What we did was we spliced into the EPS system. I made two ends come out of it, and then we attached a switch, a simple switch that would just switch the power in and out. So on one side would be the H bridge, and on the other side would be the the actual battery of the vehicle. So that's how we're switching steering systems, and we're using an encoder to know how much we've turned, and using Arduino to read the encoder values and then publish, or yes, to publish uh, turning commands to the H bridge that would go on to the motor. Uh, that's how we're doing it now. I would talk about what could be better. So not having used Arduino is great, but I would like, and then on this side is why it would have been better. So on Arduino, using Arduino has been simple and nice, but I would like that flexibility to be able to change how I control my motors directly from the console. So I'm not worried about going to the car and changing changing the code on the Arduino each time I mess something up. So I think that's an important lesson we've learned, that using embedded Linux, or like using Linux for these controls might be a better option rather than using an Arduino.
Is that so you can do over-the-air updates? Just be able
Right.
to okay, from the base station and update your
Yes.
controller.
That's that's one point. The other point is Arduinos have less memory. I mean, writing more complex programs might end up in lags. You don't want that, and just having this simple like just one computer run everything makes so much more sense rather than using different. I mean, I like the idea of having separate microcontrollers. That way, you have less. You have more redundancy, but that also comes with a cost of flexibility. So it's up to you to gauge how much flexible you want it to be. I think this is the future for robots, because uh, very soon robots are going to be like smartphones, and I think this is the way to go. Like, yeah, that's just my thoughts on it. Not having used the encoder for feedback, I like the encoder. It gives us quaternions, but it also has this issue where each time we switch the Arduino, I mean, reset the Arduino, the current encoder position would be noted down as 0. Now that might be a software fix, but I just don't know how to solve that. I'd rather have a potentiometer and have a 0 defined on the potentiometer, because the potentiometer would just have a fixed limit, rather than rotating, rather than this encoder which just goes on and on and on. So having a potentiometer would make it simpler and make it more reliable, honestly, because I mean, I trust potentiometers more. It's just me. But the other thing is, this thing costs $40. and a potentiometer would cost $2. If we blew this one up, it would just be difficult to replace, and trying to find the right encoder. But in terms of potentiometer, you can just get any potentiometer and just reset the values. Like, it's just a matter of 2 lines of codes and you're done. So that's something that we've learned from the steering system. I'll be happy to take questions on steering systems for now, if you have any.
So I mean, for the flexibility on the Arduino side, I think the Fermata and PyMata is just making a strong case over here too. That's what I've been exploring, and I think that would be something that you can try and utilize, and it will give you more flexibility at the same time. If you wanted to actually run the more microcontroller for the redundancy, you can do that too. For the potentiometer thing, yeah, you're right. That's what I just mentioned like a few minutes back. The absolute encoder actually is making the case over here. That probably can be utilized, and which has actually the digital, you can get the digital feedback out of it, and that would work really well with this kind of an system where it would absolutely remember its position every time you run. That's all on my side.
Thanks, Sam. I'll definitely take a note. And if you can share the PyMata, link to the PyMata, I'm not aware of that, and I would like to learn more about it.
Sure. Yeah, it's basically Fermata. It's the protocol that you flash it to the Arduino, and then what it makes is now Arduino takes the external commands from your computer. So now you can have any, plug it into any host computer, and then you can send a command based on the serial, the connection that you established. So it means that you're no more flashing the Arduino, you're no more limited to the memory of it. Well, obviously, you're sending the command and you're actually sensing something. So there's constant communications, which is serial, it's good for. So that's what I'm saying. That I think it's making a good case over here. We need to do the proof of concept on that so that people can start using it.
Yeah, that's really interesting, because then it's just like a USB mouse.
Correct. Yeah, exactly. You just set the commands, and Arduino works based on the commands you send. That's it.
That's great. If there are not any more questions or comments, I would like to move forward. All right. Oops. Okay, yeah, this is a bigger picture of the steering system, if you want to take a note of it. That's the EPS, the factory EPS, and as you can see here, this is where I splice the cables, and then I'm having 2 connections running out, one going to the H-bridge, the other one going to the battery of the Wolverine Yamaha vehicle. And we unscrewed this and put this in between. And these are 3D printed parts. For throttle, we used raw serial, Arduino, stepper controllers, stepper motors, bicycle cables, and a 3D printed bracket. What could have been better? Not having used Arduino again. Now, here we used a PID controller. Matt knows very well of it, how difficult that was on the Python script. Now, over here, I'm just repeating this one because in this case, we were using some advanced control methods, and it was just a PID control. But in case you want to use a more advanced control method, then Arduino would just be hindrance. Now, I didn't know about the PyMod or the thing that just Sam had just mentioned, but in this case, yeah, that's why I think having everything run on your Linux would be so much more simpler. Again, we used 2 stepper motors because the design team thought it would not have taken the load of the accelerator paddle, but in my opinion, they should have just measured how much it takes to move the accelerator pedal before deciding two stepper motors to put on there. It just, I don't know. It was just something that we missed. Now, in that case, we have two stepper motors, as you can see right here. And now the other thing was using a servo instead. I had seen Kyler's nice servo, and I'm just a fan of it after that day. uh, it's it's more easier. They make less noise, and they have a controller built in. They save space. On this one, these things make sounds when they're on. Uh, they also produce heat when they're on. So we had to make like a metal like holding box for these. Uh, these are just added costs that I would just think that could have been eliminated by use of just a single servo rather than two stepper motors and two controllers. Uh, and it adds to the flexibility too, because I mean, this is more flexible because if a controller blows up or if a stepper blows up, you can change that. But I mean, I would rather have one component to replace if anything goes wrong. It's a matter of 5 cables. Over here we have like 10 cables. We had to note down each and every cable where the thing goes and then relay it back to the Arduino, which is in the back of the vehicle. So, it's tough when you're dealing with bigger machines. Like the bigger you go, these problems arise, and like having longer cables may mean that you may lose signal uh, over time, because like, I mean, it's just a theory, but it's something to consider as well. And having reverse functionality, I would, I mean, right now we may be able to do anything about it. Like we could do something about it, but then it's all these things happen when you're building the vehicle up. So we were wrong to just assume that we don't need reverse. So it should not be there, because the function of the vehicle does not only serve the purpose that you think of it at that time, but you should also think of it in the future. So those are the few lessons we've learned from just throttle control. I'll be taking questions on throttle.
I was curious how much force those servo motors or those stepper motors do.
I think a powerful servo motor might cost a lot compared to like a stepper motor. I don't know. There's a lot out there. Maybe there's options.
$80.
Right. Yeah, that's what I saw, and that's how I found like that these cost $30 each, and then these are 15 or 20 each. So I mean, if you go about it, then there's much more you can do with like just 4 simple cables. That's what I was thinking. I'm not only talking price here, but I'm also talking about the need for less cables. It's just an opinion though. I haven't used servos. Also, using two of these steppers was difficult because we had to make sure that they turn at the same time. And then we put in a 3D printed part, and obviously it broke because it was ABS and it can't take the load it's carrying, or it's supposed to carry. That is the accelerator paddle. So we had to print these in tough resin, and then like it takes time to print in tough resin in the first place, and then there's post-processing in that for that part. And we could have printed it in metal, but then it costs a lot more. So it's just trying to use two steppers was just not, I think it was a bad decision on our part.
Did you need 2 stepper motor controllers because one wouldn't handle the current of 2 motors?
I have no idea why we had those on there. We were given this box and said, put it in there and use it. So we did.
Okay.
There was another team working on it, and they thought that it was a good it would have been good to use two steppers instead of one. But I
Well,
mean,
even with two stepper motors, you could drive them off the same controller if you wanted to.
uh, I get that point. I mean, that would just solve the problem of using, I mean, sending two signals or sending signals on over two pins. But I don't know why we used that. I quite honestly don't know. So it was just given, and then we controlled it. uh, yeah.
Yeah.
Questions, comments?
One more. Did you determine, was the throttle really hooked up? Was the throttle pedal really hooked up to the throttle, or was it electronic?
It was hooked up, so it was mechanically connected using bicycle. Uh, I have a picture right here, a bigger picture. So over here, it's really not visible, but you may be able to see a thin cable going out of there. It's like a bicycle brake cable that you slide in, and then we had a slot on this part that you slide in, and then because of tension it just stays there, so it wouldn't move. And then this bicycle cable ran throughout the car. Let's throughout here, so it went through the center console, and then over here we have a bracket that would just hold the cable there, and then the cable would come out of the accelerator and brake paddle.
Did you trace down where on the engine the accelerator connects?
We tried to. The engine was in the back. In the back basically. So it was completely inaccessible, sort of. Like trying to put something there would just have been a disaster because of the heat that it produces. So, and then one of the other problems that we had was to keep the vehicle operational, like manually operational afterwards. Like after automation, we wanted to be able to sit inside the vehicle and drive it like it normally would. So that's why this was chosen, because when you're using like your legs to manually drive it, you're just losing tension. So that wouldn't affect the autonomous system at all. So that was the idea behind using, like, connecting it to the brake and accelerator pedal itself.
Okay.
So, I agree with your the analysis of the servo thing. You mentioned reverse. What were you?
Well, since I was talking about throttle, I would assume it's propulsion. So propulsion is forward and reverse. Our vehicle didn't have reverse functionality.
Oh, I see.
So I would have preferred to have go reverse.
Right. Yeah. Okay. Cool.
I should be moving on. Emergency. I don't think we need. I mean, it did its job. It was working fine. The only thing was we were using Zigbees to control these. I'm sorry, to send a ROS message over Arduino. I would have preferred to use Arduino on this one because it's an isolated system. So if the computer, hangs for a reason, the microcontroller would take care of the rest. It would still receive a ROS message saying 1. I mean, that's the protocol. Like, that's how we set it. Like, it was 0 or 1 in terms of emergency. So about emergency, I would still use an Arduino because that's an isolated system, and since it's a mission critical component of the system, I don't think that should have changed. We at least got one thing right, I think, in that case. It was working fine, and the other thing was this one it gives you about a 200 feet range, which is still not bad, but not something that you would wanna have when you have a farm. and it's working in the farm. You need to run to that within 200 feet distance. But for testing purposes and for prototyping, I think this worked well. I have no suggestions on using different uh, options for emergency in terms of range, like in terms to extend the range, because most of those would result in a 2.4 gigahertz frequency. That's like a long range frequency, but that's still not secure. The Zigbee's is still a 2.4, and it's still secure because it encrypts the data when it sends it out, and then you decrypt it on the other board. So that's why we used the Zigbee's, because we didn't want to pick up any signals from all the other robots around so that it would just stop. So that was the idea behind it. But I mean, I'm open to suggestions, and I would really like a lengthy discussion on emergency, or on how to improve the range of emergency, and because I think that's a critical system.
So can we use the Arduino LoRa long range, the MKR chip over here? I mean, would that be a good fit if we wanted to implement that?
I am unaware of that chip. So, but yeah, I haven't come across that. So I don't know what it is, but it might be if it's a long range. Well, the thing is, they told us that the Zigbees would work for like 200 meters or something. Somewhere on the internet, it said that it's a really long range. But then when we actually tried it, it just turned out to be 200 feet. And that's practical purpose on a parking lot. So, I mean, there might be interference or something, but I'm not so sure. I'm not that much of a signals person myself, so I don't know, but that's what we practically found.
So someone you're interested in increasing the distance?
That would be something that I mean, yeah, I would like to have more control over the robot. And I mean, the ultimate goal in my mind would be to have your cell phone or something just, send an emergency message. I mean, that's something I just came up with. You can send an SMS text and then can use it or like have a GSM board on top of an Arduino. I'm just thinking out loud, but yeah, that's a possible solution to it. Just call the number and then it would just flip the switch.
I've thought of putting a sign on my tractor that says, if you see me without, or if you see me crossing the road, please call this number and have it built.
Yeah, I see the ideas already started, implementation. So yeah, I mean, that's a solution I can think of, and I just came up with it right now in this meeting. I'm pretty impressed with myself. But yeah, I think
the Arduino long range connectivity can go up to 5 to 10 kilometers. So I think that's a pretty good range.
Oh wow, that's nice. I didn't know about that at all. I'm going to note that down somewhere and then look into it. Thanks, Sam. If there are no more questions, I would like to move forward. Okay. Computing. I mean, we used a surplus computer. We didn't have a budget that big. We got a $35 computer and then we spent $700 on powering it up. It was dumb. Trying to power up the computer was more costlier than embedded system. But when we started looking for embedded systems, when I started looking for computers for the AgBot, the NVIDIA were out, but I read lots of issues about it. It had troubles being able to run ROS properly. So that's the reason why I would just And the only other option at that time for me would have been to go with an NUC, which would still cost $700 to get and then power up. So I mean, that was a major decision changer for us to be able, like, we had to just go with what we had on in that part. But I think if 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 I would if I'm trying to make a robot right now, I would go with an embedded system. I would not go with a computer for sure. And I think NVIDIA's or an NUC are great options. I don't think Raspberry Pi is great though, because it's a good test rig. It just annoys me the time it, like, for the time it takes to build codes up and everything. I know there's different options like, cross compile and everything, but I would just rather have a nicely running computer. And a part of it is because having a Raspberry Pi today that's able to run my code today would be great. I'm saving $100, for I'm getting this for $35. But I would rather like to see more into the future and try and be able to use that same computer to run different code, some more complex codes, because in the near future, when I'm bored of using the same old techniques to control my robot, I'm going to use more advanced techniques. And I don't think those advanced techniques come cheap in terms of computing. So that's another reason I have noted it here that Raspberry Pi is great for a test rig. And I use a Raspberry Pi for a test rig to just run my, to get input from my sensors or to test my sensors, or just single node operations or something like that. But I haven't ever had the courage to download the navigation stack on it and then trying to build it on there. But that's my opinion on it.
My raspberries are sitting unused. I get compute sticks for $35, and boy, it's hard to beat that.
What did you say? The Compute X?
Compute stick. You can get an Intel compute stick for $35.
Oh.
I use the Minix systems, which are more like 100 something. If I want more capability, more USB ports.
Right, exactly, and that system, Minix system, you said, and that's exactly what an NUC is. Intel calls them as NUC. They're like micro computer cases.
Intel charges more.
Yeah, exactly. But I didn't know the name of that system, so I went with NUCs. But yes, that's what I think of computing. I think that's more important than we may think. We may just think we can throw in something, but for long-term purposes, I think having a more stable computer that you can keep running your tests on and then hopefully have it working for good would be a better option. If there are no more comments on computing, I would like to move forward.
One other module, so I heard great things about the Jetson TX2 for NVIDIA. I think it's on the expensive side, but if you're looking for something industrial, that's the system to go with.
That's exactly what I got for myself very recently. I got a TX1 for myself. I'm going to try and get it working sometime.
Nice. You would have a lot of fun with it.
Yes, I hope so too. I still wish I had $100 more to go for the TX2, honestly, but at this point I'm broke.
Sure. Okay.
But in the future, yes, I'll get one for myself. Thanks, Sam. Any more questions, or I should move forward? All right. Sensors. Having more sensors is always better. I would just say that outright. I wish we had wheel encoders on there in place. I really wish we had, 2 IMU sensors on board or something. Redundancy is good, and I think for steering system, I would rather have 2 or 3 potentiometers than just one single encoder. And yeah, so I think having more sensors is great, and thinking about it beforehand keeps you in the game. Like you can't make some of these changes later when you're done with it, and then when you do testing. So if you, I mean, I would just, I wish I would just wish that everyone who's starting out or who's making a robot would know that and have those sensors on there. I mean, having a LiDAR doesn't, like, it costs a lot. So I would just say that think about it and have a future port for it or something. Like think about it in the future, maybe you'll get something, or maybe someone has it on and laying around and they're not using it or something, or you may get a donation from a company, whatever, but have a port for it, and um, I think having clarity of needs and considering future expansions was something that we lacked upon. We didn't know what we need at that time. I mean, right now, I wish the Agbot did the reverse. I wish we had like ultrasonic sensors on there in place and then connect, like, so that they're connected to the Arduinos or to the computer in the back. That would just, it doesn't mean having it there is more, it's cheaper in terms of imagination, honestly, because if you don't have it there, you won't be able to make it work anytime. If you have it there, you just might use it sometime. And it's not just about obstacle avoidance, but it's about anything. Having a camera that's facing forward, we didn't have an obstacle avoidance system, but I wish we had a camera that would just be facing forward. So, and then we can use a mux or something. So if the vehicle detects something or someone, it would just stop. And you don't need advanced LiDARs for that. All you need is a camera, and those are cheap. So, but the costlier part is to having it, like, is to have it on there after you're done making the robot. Because right now, if I want to put another camera on there, I'll need to get a mount, and then I'll need to open the things that are already in place. And I think I'm just not so confident that I can do it do it again. Like it was the rush of that and the deadline that was pushing me to do it, but I don't think I can do it. Like open it all up and then put it all back as it was again. And I mean, it's just me, but anyone might be able to do it, but I would just prefer to have it all in there at once for me, at my disposal. And that's my opinion on using sensors. Comments, questions, or should I move forward? All right. Life cycle. As I had mentioned, so it says robots aren't at the point where we can use them as any other commercial product. We can't use them as vacuum cleaners. Well, we're using robots as vacuum cleaners, but my point, you get my point. So robots are costly, and making one still it still costs a fortune, at least for me, because I got an NVIDIA. Now I'm trying to find funds to get sensors and to get motors and everything. I mean, to get actuators. So I think it costs a lot. But right now, I mean, having that capability would give me more, make me more future proof, because a robot is not a 1 year investment. It's a longer investment than you might think it is. I feel like a robot is it should be at least a 3 year or 4 year investment on, like, if you think about it. And then consider, like, I wish we had considered the pace the technology is moving, because each day there's something new coming up, and then being able to have, like, in terms of software, I think it would be great. So I'm sorry, I'm getting sidetracked, but having a computer that can run everything and having place for sensors, if not those sensors, might be helpful to be able to just plug and get it on and get it working. Because you might want to, I mean, I feel like I want to use my NVIDIA for a nice working field robot right now, but then I might also want to use it for something TensorFlowy, or on the neural network side, because I have those GPU cores. So having that functionality will make it more flexible for me. Maybe I wish to do something like a UGV that uses TensorFlow to do obstacle avoidance or something. But having that technology that at that time would be so much more important. So picking up parts and picking up sensors is much more important than we might think, because trying to get there using like trying to get a robot that is ROS ready is it's not easy anyway, and then you add these more complexities, and then when you're just there's, let's say, once you're done making the robot ROS ready, ROS 2 comes out, and then you're like, oh, I want a ROS 2 robot or something. And that I know that ROS 1 and ROS 2 are say like almost similar, and like there might not be many complexities in that case, but I'm just saying that having that different approach would would be much more uh, would be much of an advantage. So that's my thought on a robot life cycle, like having thinking about a longer life cycle than you might think. Because once you have it working, you can just use it and for the purpose you made it. So and then for workflow and documentation is tough. It's really tough. Like once you're done with it, you're just done with it. I can't sit down and write about it. It's not me. But I wish I did video logs. I know Matt suggested me to do that, but we were on a deadline and I didn't have time to spare for that. I had it all up here, and this is not as reliable as a computer, honestly. Uh, a brain. I'm talking about a brain, but yes.
A late night video log might be more revealing than you want.
I know, right? A work system by system to avoid mix-ups. I used to mix up a lot of systems. I still do sometimes. I mix up the throttle with braking, or sometimes I mix up throttle with steering. So I would recommend using like a system by system approach, trying to get one system together and then having having that system in place so that it can connect to other systems. Now, this helps when you're moving from robot to robot. Now, when we made the Agbot 3 from Agbot 2, the Agbot 3 being the Yamaha and the Agbot 2 being the small, tiny rover that looked like Mars rover, but it isn't. We literally ported the spray system from this one to the other one. We didn't have to make any changes because it was based on an Arduino. But I mean, moving forward, it would just be a matter of servo motors, and you're just supposed to connect the actuators and then have a ROS emergency subscribe to it. So in terms of ROS, I'm talking about in terms of ROS, but working system by system also makes your systems independent of each other, and that would be so much simpler in terms of troubleshooting. It's advantageous when you're doing. I mean, I would just wish I had done that, or that's what I think of it. And then having being able to document each system when you're done with it is helpful too. I mean, I wish I did that. These are all the things that I wish I did, but I didn't. So I mean, I'm hoping to do all of these things moving forward. And yes, so your robot will live longer this way, and someone can pick your work up if you decide to pause for a moment. Now I'm graduating, and the next person in line wouldn't be able to. I mean, I've done my best to do it and to make myself sit down and write stuff about it, but then there are still some things that I just know about, and it would be tough to convey them after it's made. Convey them, yeah. So I think that makes a robot more sustainable, and we're all doing open source work. So I think this part is much more important than the documentation itself. I mean, documentation is important, but sustainability is a branch of documentation. Yeah, and then if you have any overall questions or comments, please.
I think the thing that's awesome is, I mean, you point out like the key thing, like every application is going to be a little unique, right? Like, and even when you modify between Agbot 2 and Agbot 3, for instance, right? And the opportunity we have is because we're focusing on ag here with Roth Ag, it gives us the chance to kind of take things and focus it in that arena. But you also always, even in the world, I mean, we're automating forklifts and HEPs every day, and each one of them is some core capabilities, but even we take into account, you know, swap, right? Size, weight, and power, all that stuff comes into play. So you have to think about those things, running cables, is the battery going to charge? You know, if you use a lithium ion, well, then now you have a lighter weight battery, but that used to be ballast for your forklift, right? So now you have to put in these metal steel plates to kind of balance out the forklift, which is kind of hilarious because you're advanced, but you're still as heavy as you were before. So that's awesome, man. Good work. I think that's a great challenge. Be careful when you try to make final decisions right now moving forward. You may take a new challenge, and you may actually do some of those things again. Like, for instance, let me just say this one point. Like the Arduinos or whatever distributed systems, one system doesn't always mean a good thing, right? You're worried about running wires. The solution could be go to a CAN-based system or a network-based system where you have distributed sensors running on embedded processors, but they only have 2 wires throughout the rest of the vehicle. So, I mean, those kinds of things play in, but that was awesome, man. Good work.
Yeah, thanks. I think that's a good point, having a CAN bus. That's what I was going for. There are alternate options that we could have used, but we just went with Arduino because all of our team was Arduino literate, and they knew how to fix things if things went wrong. And then Arduino is a big community, so that's why we went for it. But I mean, moving forward, I think CAN bus is a great option as well.
You can still do CAN bus on Arduino. That's not bad, but yeah, you know, it's cool. You made it. You had to make those choices. That's how we roll. And limitations, right? Financial. Yeah. You're like, hey, I want that $150 sensor, but I only got $40 left. So what do I do?
Right. Yeah, we had to make money from thin air, so. But yeah. If there are no more questions, yeah, thank you for listening, and I hope it was a big helpful.
So
Hi, Colin.
I've got one question for you.
Yeah.
If you didn't have budget limits, what are the things you've rather wanted to do? Because if I get you right, it would appear like some of the things come on my budget. Are they things that you would have wanted to do and put on your ag robot that are better than what you have used?
I'm sorry, Colin. I missed it. I couldn't make something of what I heard. I'm sorry.
I'm talking about your budget limit.
Right.
It would appear that the budget limit constrained you from having the ag robot you would have wanted to have. Are there things that you would, if you had the right budget, you would have wanted to do?
Oh, yes. I mean, our budget.
I'm looking at a situation where there are 2 things that you learn from others, what you could have done better. But there are things you knew you could have done, but you couldn't do them because of limitation of budget. Well, what are those that you couldn't do because of limitation of budget? Because
of course. Yes, I understand your question. I assume I think your question is, if there were no budget limits, I could have done so much better. And what are those things that I could have done if there were no budgetary constraints? Now, let me tell you, we in the first 3 months of our project, we were given a budget of $3,000. I strongly suggested that $3,000 is not what will get you a robot. After pushing hard for it, we had $1,000 more pumping in, and then we had another $1,000 that was donated by one of the students or the group from the group. So we had $5,000 in total when we were doing all of these things. Now, if we had if we had a bigger budget, we would have gone for a better GPS. We would have gone for a Swift nav rather than reusing the MLETs, because we knew that was going to be a problem. In the end, Kyler ended up donating an IMU sensor that was working decently. Uh, so, yeah, I'm going to get you that sensor back, Kyler, as soon as I get my job. But the other thing was, I mean, we would have gone for a better computer from start. We would have gone with a TX2 in the beginning rather than getting a $35 and making a surplus computer and then making up for everything that we used for it. It took a lot of electronic calculations to figure out how much power we needed. Power systems are tough to figure out when you're dealing with AC voltages, 12 volt DC, 5 volt DC. So we had to work that part out. I mean, we had some smart people on our team, but it still takes time and trying to get everything together. We didn't use all of the standard electronic items that we should have used. I really tried to keep the cables color coded at least. But other than that, we were using connectors from here and from there and from everywhere. We would just pick things up wherever we find them, and then we'll put it on there. So it works. We just made it work. But yeah, I mean, there were so many things that could have been done in a much, much better way if we had a budget of like $15,000.
Yeah, because my fear is that as we make these ag robots, we should focus on the functionality rather than whilst the budget is very important. It's a target of what we want to achieve so that we can get a return out on what we produce. But if the functionality of what you want to produce is compromised, you won't even get the satisfaction that I've created this. Because like you were saying, I could have done this, I could not use, you should not have used this, I could have used this. These are the items. I strongly feel, at least for me,
I agree with you on that.
It's satisfaction.
It's not just about the satisfaction, because trying to save on money could also hinder your progress and your imagination of what your vehicle can do. Because, I mean, a robot car out in the field can do so much more than you can imagine, I think. I mean, there are so many applications and so many things that could be built upon it, and so that it's sustained. And in the future, I mean, I hope we see a nice tractor that's come out of all these bad decisions.
My fields, some of them are a kilometer away from my office. You were talking and making reference to a 250, you say 250 feet or 250 meters. The issue of design for me would be my ability to reach the tractor at least a minimum of 500 meters. That would be one of my requirements, that I should not come up with something that will roam around my offices, but it cannot reach 500 meters. So initially I'll have an ag boat that is within reach, that is shorter. But the aim is to have a tractor that can go to the fields up to 1 kilometer distance. So those things I have to take into account when I consider the budget. rather than the budget considering how many meters I should stretch out.
I agree with that.
I think there's a difference between budget limit and the necessary budget requirement. Because people might think that I'm not considering that we need to be saving cost. We really need to be saving cost, but I'm also saying budget limit relative to the functionality that we want to achieve. I think that would be also uniform.
Thanks, Colin.
Thank you very much.
Yeah, thank you. That's a great insight, and I truly believe that functionality comes first when we're thinking about robots, because they're robots and not.
Of course you do, because you're a college student. Money is the sky's the limit, right?
Exactly. I agree. Well, I think that's all from my side. If you have any questions, please. I'm also available on Slack or anything if you want to chat about any of the things that I just talked about. Back to you, Matt.
Thank you, Solomon. That's excellent. So would you do it again? Would you recommend others enter the competition?
Oh, yes. I mean, of course. I think it pushes everyone to come up with something new. And I mean, budgetary constraints are tough, but when you feel like you've overcome those constraints and still make something that, at least moves such a big piece of equipment, I think that in itself is it's a very it helps you push further, and it motivates you, I think, in a way. So I think, yeah, everyone should. I mean, anyone who is willing to take part in the competition. I think the Jerishes are great people. So it's, if not about the competition, just go check out their farms.
Awesome. Thanks, Owen.
Yeah.
Looks like Jeff's got a tech demo. He's playing with a turtlebot or a hamburger. I don't know what he's got.
It's the TurtleBot 3. It took 5 hours to assemble this thing today. Which
Was that the waffle bot?
it's the waffle pie.
Oh, pie.
So it's got the Raspberry Pi processor in it. They had another one that was a waffle something that had an Intel processor in it, but they discontinued that one.
I see.
Discontinue Intel. Come on, man.
I'm not sure what it was, but this is what was available, and this is what they bought. So.
Do you have a stereo camera on there?
No, it's just got a Raspberry Pi camera on the front. It's all it's got, and then it's got the like RP lidar or whatever that is, the little spinny lidar on the top. And this little board right there was supposed to go inside on the second level, but it didn't look like those cables were long enough, and the USB cable it gave me was about 2 inches too short, so I had to stick that green cable in there to make it work. So I just stuck it on top to make up for all that as I put it together. I haven't fired it up yet, so that'll be for tomorrow, I guess.
Yeah, remember that's the Robotis product, right?
What's that?
That's the Robotis product. The waffle pie or something?
Yeah, Robotis is the company.
Okay. Yeah. It's pretty cool.
And for some reason, this one costs 3 times as much as the smaller one. And the only thing I can figure out is the Dynamixel servos for this one are like $200 a piece, and the ones on the little one are $50 a piece, and that might make up. But it's still, I don't know where all the money went, but there's like $1,500 for this one, and the little one's $500. And they seem to have the same basic components on everything, so I'm not sure why that is, but
Wow.
I wasn't paying for it, so.
That's the good part.
Looks like a fun toy. We're getting at the top of the hour here. Is there any other questions, comments, suggestions? All right. Thanks for being here. Great presentation. I loved it. That was a lot of fun Thanks for your tech demo. Jeff, good luck getting that thing running. You should be able to do the full navigation stack and obstacle avoidance and obstacle classification probably in a couple days. All right. You guys have a great week, and we'll see you next week.
See you guys. Good work.
Thanks.
Thanks, Owen.
Yeah.
Thanks, Matt.
You guys.